Let's do a little tutorial on inverse functions now. Okay, so inverse means to undo something. Means to undo it. So for instance, if we had a function f of x is 2x, it's just going to double some number, right? So whatever we put in here for x, we're going to double it. So if we put a 2, we're going to get a 4. If we put a 5 in, we'll get a 10. Put in a 10, we'll get a 20 out. Okay, we can graph that. We know it's all a line. It's going to have a slope of 2, and it's going to go through the origin. But now if we're looking to undo that function, this is the notation f to the minus 1 of x. And what we want to do now is find the inverse function. I'll show you the procedure for that in a minute. It was that little handout we had. But I know that to undo multiplying a number by 2, I'm going to divide a number by 2. So x over 2. Okay. And so basically what we want here is x and f to the minus 1 of x. And try not to get mixed up on these variables. But now our input to this new function is the output of the old function. Okay. So what I'm saying is if I put a 4 into this one, I want to get this value out too. And sure enough, if I put a 4 in here, 4 over 2 will give me 2 out. I take 10, which was the output of my first function, move it over to here, and so for 10 into this new function, f to the minus 1 of 10 is going to be 10 over 2, which is 5, and 5 is what we were looking for over here, okay? And so you can see the same thing's going to happen with the 20 in, we'll get a 10 out. Okay, the procedure for finding an inverse function is this. So let's try it with that same example. We had f of x was 2x. Here's our procedure following that little half sheet that I handed out. First thing, we solve for x. Okay, so we're going to get, doing that up here, we're going to have to take, divide this by 2 and divide that by 2. 2 over 2 gives us 1. So now our solution to this is x is equal to f of x over 2. Okay, so we solve for x. Second step is to replace x with f to the minus 1 of x. Okay, so over here we're going to get f to the minus 1 of x. And our next step is to replace f of x with x. So back up here we're going to get x over 2. Okay? So regardless what kind of function, this one we had a linear function, doesn't matter. You solve for x, then you just do these variable substitutions. One last thing that I'd like to show is when we compose the functions, and a couple things I want to show. So let's talk about composing a function. So we take a function and compose it with its inverse. So f of f to the minus 1 of x, which you may also see written sometimes as f composed f to the minus 1. And what we do is we take f to the minus 1 of x and stuff that into the variable for our function. So we take this x divided by 2 and we put that into x in our original function, f of x equals 2x, okay? So now we're going to have, this is going to be equal to 2, and now our x gets replaced with an x over 2. And multiplying this times this is just going to give us x, which is what it should do. A function in its inverse should give us back x no matter what if we did it correctly. And just to show you, this will also work if we compose an inverse with its function. Okay, f to the minus 1 of f of x equals f. This is just another way of writing f to the minus composed of f. And what we do is we take f of x, let me change my pen color here to help us out a little bit. We take f of x, which is 2x up here. F of x is 2x. And we put the 2x in here into our x over 2. So we're going to get 2x is where x is, divided by 2. 2's will cancel, we get x. So this function and its inverse check out. The last thing is graphically what is happening here. So very crudely here, f of x equals 2x is going to be, let's say, a line like this. It's supposed to be going through the origin there. Okay, and f of x equals x divided by 2 is going to be a line going through the origin with a much smaller slope. Okay, and the point being that these should be reflections of each other across the line y equals x. So if you think about that, if we were able to fold this graph in half along that dotted line, the black and red lines would line up together. So you may see something where if you the other really big thing is that exponents and logarithms are inverse functions of each other. So if we look at an exponential function, it might look something like this, and then its inverse is going to look something like this. Okay, and what that is once again a reflection across the line y equals x. So if we fold it on this line, that's what we'd get. Okay, clear as mud.